Okay, let's get started. As you know, today I promised to take you on a walk through the solar system. So let's start here with the central object of our solar system, the Sun. As you can see, the Sun is about 5 inches in diameter, and that's about the size of a large grapefruit, which is exactly what I've used to represent it here in our model. So I'm going to take 2 steps. That will bring me to the planet closest to the Sun. That would be Mercury. 2 more steps to Venus, and 1 step from Venus to Earth. Let's continue walking 3 steps from Earth to Mars. And that's as far as I can go here in the classroom. But we can visualize the rest of the journey. Don't bother writing this down. Just stay with me on this. So, to go from Mars to Jupiter, we'd have to walk a little over half the length of a football field. So that would put us about at the library here on campus. And then to get from Jupiter to Saturn, we'd have to walk another 75 yards. So by then, we'd be at Harmon Hall. From Saturn to Uranus, we'd have to walk again as far as we'd gone in our journey from the Sun to Saturn. And so we'd probably be at the Student Union. From Uranus to Neptune, we'd have to walk the same distance again, which would take us all the way to the graduate dormitory towers. From Neptune to Pluto, another 125 yards. So we'd end up about 1/3 of a mile from this classroom at the entrance to the campus. Okay, that's interesting. But now I want you to think about the orbits of the planets in those locations. Clearly, the first 4 planets could orbit fairly comfortably in this room. But to include the others, we'd have to occupy an area of more than 6/10 of a mile, which is all the way from College Avenue to Campus Drive. Remember that for this scale, the Sun is 5 inches, and most of the planets are smaller than the lead on a sharpened pencil. Okay, with that in mind, I want you to think about space. Sure, there are some moons around a few planets and a scattering of asteroids and comets, but really, there isn't a lot out there in such a vast area. Well, it's pretty empty. And that's what I really want to demonstrate with this exercise. Now, it would really be even more impressive if you could actually make that walk. And actually, you can if you visit Washington, D.C., where a scale model is set up on the National Mall, starting at the National Air and Space Museum and ending up at the Arts and Industries Museum. I did that a couple of years ago, and it was, well, amazing. Even though I knew the distances intellectually, there is nothing like the experience. Has anybody else done that walk?
I have, and you're right, it's an eye opener. It took me about 20 minutes to go from the Sun to Pluto because I stopped to read the information at each planet. But when I made the return trip, it was about 10 minutes.
Did you take pictures?
I didn't. But, I don't think it would have captured it anyway.
I think you're right. What impressed me about doing it was to see what was not there. I mean, how much space was between the bodies in the solar system? And a photograph wouldn't have shown that. So, back to our model. Here's another thought for you. The scale for our model is 1 to 10 billion. Now, let's suppose that we want to go to the nearest star system, the neighbor to our solar system. That would be the Alpha Centauri system, which is a little less than 4.5 light years away. Okay, let's walk it on our model. Here we are on the east coast of the United States. So if we want to make it all the way to Alpha Centauri, we have to hike all the way to the west coast, roughly a distance of 2,700 miles. And that's just the closest one. To make a model of the Milky Way galaxy would require a completely different scale because the surface of the Earth wouldn't be large enough to accommodate a model at the scale of 1 to 10 billion. Now, let's stop here for a minute because I just want to be sure that we're all together on the terms solar system and galaxy. Remember that our solar system is a single star, the Sun, with various bodies orbiting around it, 9 planets and their moons, and asteroids, comets, meteors. But the galaxy has a lot of star systems, probably 100 billion of them. Okay? This is important because you can be off by almost 100 billion if you get confused by these terms. Not a good idea. Okay, then. Even if we could figure out a different scale that would let us make a model of the Milky Way galaxy, even then, it would be challenging to make 100 billion stars, which is what you'd have to do to complete the model. How many would that be exactly? Well, just try to count all the grains of sand on all the beaches on Earth. That would be about 100 billion. But of course, you couldn't even count them in your lifetime, could you? If you'd started counting in 1000 BCE, you'd be finishing just about now with the counting, I mean. But of course, that assumes that you wouldn't sleep or take any breaks. So, what am I hoping for from this lecture? What do you think I want you to remember?
Well, for one thing, the enormous distances.
And the vast emptiness in space.
That's good. I hope that you'll also begin to appreciate the fact that the Earth isn't the center of the universe. Our planet, although it's very beautiful and unique, is still just one planet orbiting around just one star in just one galaxy.